Alright, so I'm at section 6.9 here, and it's again using triangle theorems to prove that triangles are congruent. These are just a little bit more complicated, and I have this triangle here. It looks pretty similar, but you may notice that there are no values here. All it tells me is that angle RPT and angle CTP are supplementary. And if you remember what that means, that means that this angle and this angle, if I add them up together, it equals 180 degrees. You remember the difference between supplementary and complementary, because complementary adds up to 90, supplementary adds up to 180. C comes before S in the alphabet, and 80 becomes before, or sorry, 90 comes before 180 on a number line. So that helps you too. We're going to try to prove that the little triangle is similar to the big triangle. Okay. So first things first, we always write down our given statements. Or angle RPT is supplementary to angle CTP as given. Okay. Then where do we go from here? Well, the only thing we really can do is, if you really don't know where to go from here, is you can, well, I know that the definition of supplementary angles is that the measure of angle RPT plus the measure of angle CTP must equal 180. So this plus this equals 180. Well, if I have this, so that means that the angle of the measure of CTP plus the measure of CTM must equal 180, because that's a linear pair, right? So I'm starting to unravel some stuff. Right, so I'm going to say that the measure of angle CTP plus the measure of angle CTM equals 180. Right? Well, first we'll say the supplementary. Because it's a linear pair. So measure, we'll say a CTM, angle CTM, and angle CTP, angle CTP are supplementary, right? Because they form a linear pair. Linear pairs are supplementary. That's cool. That means that the measure of angle CTM and plus the measure of angle CTP equals 180. That's because of the definition of supplementary angles. Angles. All right. So I know now that these two angles are the same, but how do I say that? Right? Well, I can say that where can I go from here? Actually, is what I guess what I'm thinking. What am I trying to like? What am I trying to solve here? I'm gonna get like an angle. I want to get like two angles are the same. I already have one angle are the same, or maybe I can get like two sides are the same, but two angles are like the best way to go here. So, like, see if I can figure out some stuff. Oh wait, like this is the same thing here. Okay, so how do I say this on here? All right, so I pretty much figured this thing out. I just got to figure out how to put it down here. Okay, so I've pretty much said that this angle and this angle are the same. I've identified that, and I've identified that this angle is shared. So how am I gonna write that down here, right? So I have CTM, I have CTP in the same one here, and I have CTM here. Okay, so I have 180 there. So what I'll do is I'll say that okay, yeah, so if this equals 180 and this equals 180, right? Yeah, there we go. Yep, that's what we got to do. Yeah, so if this whole value, and that whole value both equal 180. Oh, you can't see what I'm doing. All right, if this whole value and that whole value both equal 180, right? I bracketed them off. They both equal 180, and both of them contain the angle CTP, right? So then what I'm gonna do is I'm gonna get rid of that 180 and I'm gonna set them both equal to each other, right? A equals B, B equals C. That is the transitive property of equality, right? So I'll write that in blue. The measure of angle RPT plus the measure of angle CTP equals the measure of angle CTM plus the measure of angle CTP. Oh, that's tiny. Zoom in on it. Right? That is the transitive property of equality. All right, so there we go. That I had some, so I was able to identify that I have this property in both of my statements. They both equal the same thing, and now I want to set those equal to each other, right? And now I can go like this. I subtract them from both sides. Now I have the measure of angle RPT equals the measure of CTM. Right, CTM and RTP. Now that's how you actually state that, right? Oh, I don't see it. Crap. Right? So now that I was able to like get rid of those, I was able to say that those equal to each other, right? But how do I actually say it with the words is that way, right? So I know that those are equal to each other, right? But I need to get rid of that angle, CTP. I need to get rid of that algebraically, and that's how I did it, because of the transitive property, right? This was common between both of those, so I set them equal to each other, and I subtracted that from the middle. And then that was the substitution, or the subtraction quality, or property of equality. Okay. All right. So the next one, yeah, we have to say that these are congruent with each other because measures. So angle RPT is congruent to angle CTM because definition of congruency. Sweet. So now we can say that those are congruent because measures are not congruent. Measures are equal. All right. Sweet. Now we're back to measures. All right. Now we can just talk about this one here. This one here is equal to itself. Measure of angle M, or angle M is congruent to itself. Angle M, that's the reflexive property. And then now you can say that the two triangles, yep, that's congruent to itself. Now you can say the two triangles are congruent or similar. The two triangles are similar because of angle similarity. All right, so that one was a little bit more complicated, right? You had to use transitive property, a little bit of substitution, because of the supplementary thing. Pretty cool, huh? I thought that was cool. Little brain teaser there. All right, now we'll go on to, I'll pause it and prepare the next one. All right, so here's an interesting one. We have this little triangle, it's a right triangle, inside of this bigger right triangle. This one's RWT, and this one is TVW. All right, and we have to prove that they're similar. All right. So the first thing that we're got to say is that WT is perpendicular. WT is perpendicular to TV because that's what's given to us, and that WR is perpendicular to RT. Those are the given statements because that's what's shown to us. All right. So what do we go from here? All right, so what are we gonna try to work toward? Do they share any common angles? Maybe. Let's see if we can work toward that. All right, so VTW, they definitely VTW. VTW is a right angle. Right? So VTW and WRT are right angles. So we'll just say that right away. WRT and VTW are right angles. And that's the definition of perpendicular lines. Okay, and then we're going to say that the measure of angle WRT and the measure of angle VTW equal 90 degrees. Or we can just say like this. Measure WRT equal 90 degrees. Measure of angle VTW equal 90 degrees. This is the definition of right angle. Okay. So you can then say that the measure of WRT equals the measure of VTW. That's the substitution property. Or you could say that's the, I can actually even say that's the transitive property. Either way. Whoops, what happened? I knocked the thing out of the way. That's substitution or transitive. Either way you want to do it. So that could be your A, that could be your B, and that could be your C. Okay, and then therefore you could say that angle WRT equals is congruent to angle VTW. Congratulations, you just proved that two right angles were congruent. There's a postulate for that, but I don't know why they needed to do that. But anyway, okay. So they did that in like 6 steps. I did, or like 8 steps. I did that in 6. So I just combined the two. Okay, then you could say that W is congruent to W because of this. That's the reflexive property of congruence. Well, W is congruent to W because of reflexive property of congruence. And since that one shares the angle with both, you now have these two angles that are congruent, right? So you now have angle. You have the two triangles are similar by angle similarity. There you go. Yep. So this angle is similar because they're both right angles, and this angle is similar because they're both right because they're both shared. So you only need 2 angles that are similar. It didn't stick right out at you, but it is true. You can actually just flip that guy around. So there you go. So I hope that one helps. There are some more you could try out in your textbooks, but I'll give you some also to try out on.